Alright guys, so in this video we're going to look at the 5.1 practice, just in case you need some assistance. So basically the goal for this lesson was, be able to construct the probability distribution, be able to determine if one is valid, and then basically look at discrete versus continuous. Alright, so for number one, we're looking at whether it's a probability distribution or not. So we're determining validity. So remember that there were two conditions. One of the conditions is that the probabilities add up to 1, but the other condition was that the probabilities are between 0 and 1. So in this example, if I look at A, I'm looking at this guy. This guy is not between 0 and 1. So not between 0 and 1, so it is not valid. Okay. For part B, again, we're looking at this guy. So not between 0 and 1, so it's not valid. Alright, and then looking at part C, we've seen that condition 1 is valid. They're between 0 and 1, so then we are going to go ahead and add the probabilities and see if they work out. So 0.3 plus 0.4 plus 0.2 plus 0.1. So that's 0.7, 0.9, and that's 1, so that checks out. And then the probabilities are between 0 and 1. That checks out, so that means this is valid. Alright, so for number 2, state whether the variable is discrete or continuous. So the number of cheeseburgers a fast food restaurant serves each day. So this is the number of cheeseburgers, so that means that we're looking at something that's counted. Alright, so this is clearly going to be a discrete variable. Alright, the weight of an automobile. This is something that is measured, so therefore this would be expected to be continuous. You can take on decimal values. The blood pressure, that's also measured. Alright, so therefore that would also be continuous. Construct a probability distribution for the data and draw a graph for the distribution. So last, number 3. Okay, so let X be the number of tails in a 3-coin toss. Construct a probability distribution for the random variable X. Alright, this is sort of like the one that we did earlier. Here, instead of doing heads, we're doing tails, but it's still going to be the same thing. Again, remember the sample space. Let's go ahead and list out the sample space. We can have no tails, 1 tail, we can have 2 tails, or 3 tails. Alright, so we have our number of tails, we have our probability. We can have 0, 1, 2, or 3 tails. So our chance of getting no tails is 1 out of 8, 1 is 3 out of 8, 3 out of 8, and 1 out of 8. Okay, so in this case, we just want to construct a probability distribution. We don't have to graph it, so we're good. We are done with A. So for part B, we are looking at a drop-in mathematics tutoring center, each teacher sees 4 to 8 students per hour. The probability that a tutor sees 4 students in an hour is 0.117, 5 students 0.123, 6 students 0.295, and 7 0.328. Find the probability that a tutor sees 8 students in an hour. Right, so we have our probability distribution where X is the number of students one sees in a particular hour. So we have 4, 5, 6, 7, and 8. Alright, so in this case this will be a discrete variable, the number of students that you see per hour. And it's limited to 8 students because that's what the first sentence says. Alright, so for 4 it's 0.117, that's our probability. 0.123, 295, and 328. So in this case we are looking for 8 students. So remember that the probabilities have to add up to 1. So therefore, if we add these guys, subtract it from 1, we're good to go. So we are going to add these guys together. Alright, so we're going to go ahead and add these guys. 0.295, so you get 0.863. So in this example, so we get 0.863, and then we know that 1 minus 0.863 will give us the answer. So we're going to do 1 minus 0.863, and that will give us 0.137. Alright, so that goes here. And that's our answer for that question. They are also asking for us to construct a probability distribution, which is what we did, and then draw the graph. So you're just going to quickly draw the graph. Now you can go by whatever you want here. My smallest is 0.117. So what I will do is I would probably start at 0.1 and then go by 0.2s, something like that, maybe. Let's see. Maybe go by 1-1s, something like that. Here, let me give myself some more room here. Alright, so that's a probability, and then here it was the number of students. So we have here 4, 5, 6, 7, and 8. So for 4 we got 0.117, so it's pretty close to 0.12. For 5 is 0.123, so it's a little bit above this guy. For 6, it's 0.295. Ooh, I didn't even see the 0.295, so in this case we need a bigger set of numbers here. I didn't even see that. Okay, so we need to reassess here. So we need to go from 0.1 to 0.3 almost. So therefore, what I'm going to do is I'm going to start maybe at 0.1 and then maybe go by 0.15, 0.2, 0.25, 0.3. That would work. So I can go by 0.150. Alright, so now we can go ahead and draw it. So for 4 is 0.117, which is a little bit below halfway. 0.123 is about halfway. 0.295 is almost 0.3. 7 is 0.328, so it's above the 0.3 mark. And then the last one is 8.137, so above this guy. And there's my probability distribution. Alright, so in this case, I have to adjust the values, but that's fine. Sometimes you got to find the scale that works for you. And in this case, we went by 50s. Alright. And that's it, guys.